Thanks a lot for joining the presentation today. I hope you are not that sleepy after lunch. This is the AI content creator. I'm really happy to present you this project. It's one of my favorite of my entire career, 8 years in GetYourGuide. My name is Marco, and I am a senior data scientist in the supply data product team of GetYourGuide. Let's first start with introducing GetYourGuide, if you don't know about it. This is one of the leading marketplace online for travel experiences. We are a two-sided marketplace where on one side we have our travelers who want to enjoy their trip and they book their travel activities. Today we have been already selling to them more than 200 million tickets. And on the other side of the marketplace we have our suppliers, which are our amazing companies who run the trips and the tours on site. And they create and generate the activities on our platform. Today we have over 155,000 activities listed online. You can imagine that at this scale it's quite challenging to maintain high quality content for our listed activities. Therefore, one of our team mission is to help suppliers creating quality activities and also maintaining the activity throughout the life cycle of the tours. Cool. I will cover. I will divide the presentation in 4 sections. So first, I will show you what is our business problem. Then I'll show you a recording of how the feature looks in production, so you can have a concrete sense of why we built it and how it works. Then I will cover how we develop the product with more technical setup, and then I will show you all the experiment journey we had and the learnings. Great. Let's start from the business problem. Creating an activity in our company requires a lot of text. Here you can see an example of one of our great activities that we have. I highly recommend this one specifically because I did it. It's a great Berlin tour. You can create a painting by spinning a wheel with an awesome instructor, and you can also bring the painting home. I recommend it. Creating an activity like this requires the supplier to write a lot of content. As you see on the page, we have the title, the short description, different text section, highlights, full description, inclusion, exclusion, and many other sections as well. As you saw, this amount of text might result a supplier to produce suboptimal content. Sometimes they don't know our desired standard. Sometimes they cannot speak good English. This results in the suboptimal text, like you can see here, uninformative titles with, in this case, a boat tour just saying private tour. On another example here with highlights being a list of locations instead of engaging text that display the unique selling proposition of the activities. At the same time, suppliers have often existing content of high quality written in other platforms. It can be that the activity is listed on other websites, or they might have a travel blog or other documents. And we really believe that suppliers should be able to leverage this content to be able to write the content on GetYourGuide without much effort. With that, I can show you the feature recording so that you really can understand what we did, and we can follow better the presentation of the technical setup later. Let's see it. This is our supplier portal page where our suppliers can create the tour. Starts by reading some instructions, and then the supplier select the product language and the product category. After that, I can continue. We access our tool, the automated content creator, and here the supplier can choose the option of copy-pasting existing content in this box. And then by clicking on create content, our algorithms are running, magic starts happening. You will see in a few seconds what the output is. So the text, after the AI icon blinking, starts being automatically auto-generated, and at this point, supplier have the chance to click on continue, accepting the text, or as well to edit it and improve it further manually. By clicking continue, the AI algorithm runs and pre-fill all the other sections as well. And as you can see, supplier can scrutinize the text and edit it because they are the final controller of the quality anyway. Great. Let's go back to our presentation. Yeah, you have seen how the algorithm predicts automatically free text, but it's also important to mention that our models are able to predict as well structured information, some categorical variables. An example here is the type of guide that we have for the tour. The algorithm already pre-select the right class. Okay, now that we understand the feature, we can go in more technical details of how we develop the product. Let's start with the architecture. Our jobs for data processing, for training, and also for evaluation of the models run on Spark clusters, which are managed by Databricks, and our jobs are orchestrated in Airflow. The model training creates an OpenAI model that is stored as an MLflow artifact, which is served in a web application built in FastAPI, deployed in Kubernetes with deployment managed by Argo. Then finally the model can reach supplier, which can send a request to the API and get the responses. All the process is observed with different tools. We use Datadog for live tracking of the main metrics and the API responses. We use Kibana for loggings, Arise for inspecting the traces of the LLM, and Looker for business reporting. Great, now let's go a bit deeper into what kind of models did we build. So as you saw in the recording, everything starts when supplier add this input text in the supplier portal box. Then by clicking on create, two models are running under the hood. The first model is a GPT-4o fine-tuned model that is used for the generation of the free text sections. This is, as you saw before, the title, short description, and until the full description. Fine-tuning is great when you want to adapt raw text to a given standard. In this case, what we want is the GetYourGuide content standard. And it's also great because you can train the model via passing examples instead of setting the examples in long prompts. You can see an example here of what kind of data do we pass to the fine-tuning algorithm. So for each tour, we send two columns. The input is the raw text that suppliers passes in the text box, and the output is the text we want in GetYourGuide style with all the sections, the free text sections. Moving on the bottom, the second model that we build leverage the function calling API and is used to pre-select the structured data that our supplier needs to fill for setting the tours online. These are fields like the transport type used in the tours, if the tour leaves the city or not, the guide type as you saw before, what items the customer should bring. We use function calling because it's great to extracting structured data from free text. You can specify the exact schema output that you want, and you can as well specify the expected values for each of the variables. This is very important because in our database, we have to stick with the terms which are available for each section, so we don't want the algorithm to just predict any text. We want to specify enums. Let's go now to discussing more what were our main challenges from ML side. One of the challenges was the generation of the training data for the fine-tuned data set. At the beginning of the project, we didn't have this input text from supplier. We didn't have an exact idea of what supplier might will copy-paste in that box. So we have to come up with some proxy text for that. And we also didn't have the reference output text because, as you saw before, our text contained defects, so we couldn't just take for granted the output text as the desired one. So it required a lot of trial and errors, human in the loop, to arrive to a good training data. The second challenge was, like always in LLM prompt engineering, we had to do a lot of iteration on the function calling method to define the schema correctly, to make sure that all the fields predicted are what we wanted for every variable that we extracted. And also for fine-tuning, you might think that by passing examples you solve the problems, but we also find out that tuning the system prompt and user prompt was also needed to get the output we wanted. Third challenge was about the update from OpenAI side that, especially at the beginning of the project, forces us to change the models, migrate to a new version, which often caused different behavior to what we were using in previous model. So we had to adapt the prompt again to recover and improve the performance. And last challenge, which was the most important for us, was about the hallucination that were in the model output, which in our context means that the predicted output contained extra information that was not really present in the raw text of the supplier. Let's go a bit more deeper into this part because it was very important for us. So let me introduce the evaluator, is how we call the tool that we use to reduce the hallucination. So at the beginning of the project, we didn't have any automated solution to evaluate our AI models. So this prevented us from iterating quickly because at each model run, we would see an output and we had to read it and evaluate manually if that was better than the one before. So we quickly realized that we needed an automated solution, and we focused on our most important problem, which was the hallucination. So we developed another AI model that could automatically detect and classify these hallucinations. Let's see an example. The supplier input might be a tour where a customer are reaching the top of a mountain. AI can be very funny and can add some extra information, like deciding that you take a cable car to reach that mountain. This is not something we wanted because we cannot be sure that this is the case. So in this case, our evaluator output tells us the information we want. It automatically detects that the cable car is an extra information added, and it are also able to classify the hallucination in specific type, so we can better understand what's going on under the hood and iterate on the training data to fix these problems. What were the results of the evaluator? We evaluate the precision and the recall manually with the content team of this tool. We achieved 82% precision and 90% recall, which were numbers that enable us to move to production with this. This really helped us in iterating quicker and faster on the prompt and training data set, so we could understand the right data quantity and data quality for the training data especially. And also, more important, these allow us to report the hallucination in production. It's still possible that the algorithm produces hallucination, but with this tool that runs daily, we can report them to the content team so they can act and correct them. Here is an overview of how our monitoring looks like in Datadog. So as you saw before, hallucination is a critical metric for us, and we track the percentage of activities which are created within hallucinations. We also track the percentage of time that the AI output is beyond the character limitation. This is what stands here for long text. Our supplier portal has fixed limitation for each text, and we must ensure that the output is within the limits, and sometimes it doesn't happen, so we have this metric to capture that. And on the bottom, you can see another process that we have where our content team receive a set of tours of activities generated with AI and generated fully manually. So the content quality can be compared for the two groups, and we can assess if the AI generated tool are better quality. And we also monitor the health of the service with checking the number of requests and error rate of the responses. Let's now move on our experiment journey and the main learning we generated throughout all the more than 1 year of project. Yeah, as you might be familiar with, experiments are the key to generate learnings. Therefore, we invested pretty soon in the project to have a solid experiment framework for our project. We set up an A/B test in our supplier portal where suppliers were randomizing after accessing the product crate menu in two groups. The control groups had the standard manual flow with no access to the AI content creator, and in treatment, the supplier had the ability to copy-paste this text, use the AI, or they can also add the option to skip and proceed manually, because some suppliers just don't want to use the AI at all. What was our journey? So we ran 4 different experiments before seeing significant positive results on both supplier and traveler target metrics, which helped us to remove the feature in production. Everything started in Q4 23, where we first launched a feature flag with only the fine-tuned model. This was done to assess the interest in the AI solution and get early learnings. We got positive signals, and in Q1 24, we launched the first real A/B test. We improved the training data for the fine-tuned model. We launched the first version of the structured field model, and we also had some UX improvements. The results here were mixed. We have some positive results, but not significant. And we also saw not high adoption of the AI feature. But we were convinced of our bets, and we continued iterating. Q2 was the game-changing quarter for us. We improved the training data, especially with the help of a refined evaluator. We drastically removed the hallucination in this quarter. We launched some significant UX improvements. We added these AI animations, icons, that help supplier understanding what's going on under the hood. We also wrote better introduction. And we also launched another feature, which was the ability for supplier to use a URL instead of input text. And we will run a scraper under the hood where we will parse the content, and we will run the algorithm with that content. This specifically didn't work that well for us. We encountered a lot of errors while scraping. And we also found that the supplier didn't use the scraping function as much as the copy and paste text. So in Q3, we decided to deprecate this feature. We ran another experiment with another UX improvements, with better setting of expectation. We added signals, recommendation clearly for the potential impact, because we knew it from Q2. And we also moved the skip button, which really helps adoption. I can show you a bit more in a second. What were the results? We observed 3% uplift in submission rate, which is the probability that the tour is submitted to be online after being created. We reduced the content quality by 7% across all the text generated, and specifically minus 17% on the free text section, which were the section which usually the most errors. And this was as well the highest rated feature across all the year from our suppliers, 4.6. And even more amazing, we saw that the new activity created with the AI on the B side had a much higher conversion rate as compared to the activities created in control group, plus 28%. So after seeing this amazing result, we rolled the feature to our suppliers. Here I summarized a bit the learnings that I got throughout this project. The first one was that high data quality was really important for the fine-tuning, even more than the data amount. At the beginning, we were throwing to the algorithm a lot more rows without carefully reviewing it, but then we quickly realized that just by having a small set with highly reviewed quality examples representative, we will achieve better outcome. Second learning was that hallucination can actually be measured effectively and reduced with the custom evaluator. This was also a big learning, because at the beginning of the project, we were quite worried that we couldn't really reduce this type of problem from LLM side. Third big learning was about the URL. We were having a high bet that our supplier would prefer using the URL over the copy pasting, but this was not the case. And the fourth learning is about how UX changes were critical for supplier adoption. I'm going to cover now here more in detail this learning. At the beginning of the project, we launched the page of the automatic content creator, as you see on the left. This is a screenshot from one of the earliest iterations in Q2, if I remember. We have an introduction which is textual. We have the ability for suppliers to copy-paste the content and import content from the URL. And then we had at the bottom of the page the skip button to display the ability for a supplier that they can still go and proceed manually. and our button create content was grayed out at the beginning. This setup really created below expectation adoption of the tool. So this was below the expectation we had at the beginning of the project. And therefore, we iterated a lot on this page. And we launched a new screen with clear step-by-step expectation of what the supplier will be able to do with the AI tool and what the supplier cannot do with the AI tool, which was also important. And also we added clear metric uplift and conversion rate up to 28% because we saw in previous experiment to convince our supplier to use the tool. And also we moved the skip button from the skip and proceed manually button from the bottom of the page to the top by leaving create content button blue. This might seem small changes because it's just a bit changing how the user click, but this is a drastic effect of how the user decide to use or skip manually. So that's a testimony of how UX can be important for a kind of project like this. In Q2, we ran the first iteration of our AI model. We ran another experiment where we compare a new version of the AI model compared to the control production model. This was the first kind of experiment of this kind because, as you saw before, we were having as a control always the fully manual flow. Here instead we compared an iterated AI model versus the other AI model. We upgraded the models to a more recent version for the fine-tuning, GPT-4o also for the structured field model. And we also recreated the fine-tuning training data from scratch because at this point we could use the real input data. As you remember before, at the beginning we didn't have this data because we never collected it. But after collecting a significant amount of this data, we could retrain it with the correct data. And we also decided to try something new. We customized the output depending on the tool class selected at the beginning. So if you remember from the recording, before inputting the text, the supplier decide which tool category it is. And based on that, we wanted slightly different text output. And so we trained the model to be able to predict different text depending on different product category. This had an impact on the quality in general, measured manually by our content team, but with more tangible metrics, we saw 17% less content defect. We reduced the hallucination by 50%, and we almost remove all length issue with an impact of minus 90%. Let's summarize now what were the key takeaways throughout the project. The first one, as mentioned before as well, so fine-tuning is really a powerful tool. Can be used to adapt raw text to any other style. It can also be used for predicting fields, and it can work with really few high-quality examples. At the beginning of the project, we didn't know if we needed a lot of rows for this, but what we found out quickly is that few quality examples can really change the output prediction really significantly and get you much better output suited to your specific task. Second takeaway is that having a custom automated evaluator really drove the confidence in our model and increased iteration speed. We started the project by having some standard evaluator which OpenAI offered to track hallucination, but this didn't really work for our use case. And having dedicated time to build a custom solution, to train the model to understand what kind of hallucination we wanted to detect, we were able to classify, understand what's going on, changing the training data rows, and also sending this data reliably to our content team so that they can take action on that. So this helped us iterating and getting confidence on the model. Third key takeaway was the importance of, in our project, of having a cross-functional team to success. So just by having an AI model, we wouldn't have the same results we got, like with the UX changes, especially were critical for our adoption, which drove the metric significance. Having human-in-the-loop processes with the content team, help us gaining confidence about the quality, iterating on the training data, and of course also analytics was great in measuring all this data for us. So with that, I want to thank you a lot for listening to this presentation and following through. Also a big thanks for my colleagues, because I didn't work on here alone, especially the catalog team and MLOps team that helped a lot in the project. Thank you very much.
Thank you, Marco. Thank you for the presentation. Now we have some questions from the video website, and then when we're over, we will go also from the attendance. So first question. Before fine-tuning, did you experiment with prompt engineering out-of-the-box LLMs? I would expect state-of-the-art LLMs to be already really good at such tasks without fine-tuning.
Yes, we did try. It didn't really work for us as well as fine-tuning. We had to adapt our text to a lot of examples of text written differently with different input text. So I think if you want to train with a standard prompt, you will have to pass a lot of examples anyway in the prompt, which is not ideal, and fine-tuning just make this process much sooner and much faster. You also get an object that you can serve easily to an API.
Next question. Why GPT-4o for this specific use case? Have you tried other models?
So we started with the first version of that OpenAI was releasing for fine-tuning. This was 3.5. That was the only model that had fine-tuning. And when they launched 4o, then we immediately upgraded the model and retested the implementation, yes.
What type of model is the evaluator?
The evaluator now runs on GPT-4 Turbo. It's a bit older model. We tested against the 4o and we saw slightly worse result than Turbo. So we kept it like this for now, but might be that we migrate it soon to other models.
The last question here, and then we go through the people here. How often do you retrain your LLMs?
The training data, we have iterated a lot before launching into production, but once we have fine-tuned it again, then we don't really retrain it if we don't need to, because by retraining you can even change the model performance, because it's not deterministic methods. So yeah, we checked it and retrain it on test methods, but we don't release it in production, new training models.
One question from the audience.
Thank you for your insightful talk, and specifically it's nice to see some really practical applications of LLMs. So I wanted to ask, so why among all the possible features and problems of the models did you have such a specific focus on hallucinations? So it looks like that in case of a product, if customer found some unreliable detail in the description, they could just erase it, so it wouldn't lead to the failure.
So can you rephrase the question?
So to sum up, I wanted to ask, so why specifically in your project you focused on hallucinations of the model?
Okay, yes. Yeah, great question. So we could tackle the quality of the algorithm in many different angles, right? There can be, we track also different metrics like the tone of the text, the grammar errors, but we decided to be focusing on a specific metric to have more focus and a clear measurement for quality. And we decided that the worst problem for us was customer reading text, which the supplier didn't have in their text, because this can create wrong expectation for customers, right? If you say to customers that they do something, but then when they go to the trip, then the thing is not happening, it's very bad for our business, can also trigger refunds. So we decided this was the most critical issue for us, and we decided to tackle that with the targeted tool, and then we had other tools to have content quality in general.
Thank you for the presentation. It's amazing. After the evaluator detects hallucination, have you considered to use the output of the evaluator replace the original text, the AI-generated text, to rewrite the text, the content?
Yes, basically how we used the evaluator was that once we understood what kind of hallucination the model was producing and classified them in different groups, then we could really see which rows in the training data was driving those hallucinations. So we iterated on the training data, we changed those rows. We also have some specifically dedicated solution, which I didn't show it here, but one of our biggest problem was that the AI model was producing location names which the supplier didn't have put it, because, for example, the raw text might not have the original location of the tour, and the AI model in that case will just guess the location. So for that, we added as well a placeholder where the AI model will predict, instead of the location, a placeholder that our supplier can replace during the live product. So we took basically once we understood the hallucination, we took different solutions to be able to reduce them, and this was effective because throughout the project, we reduced it to quite a significant the metric, yes. Make sense?
That was the last question. We are a little bit over time, so thank you very much, Marco, for the presentation.
Thank you.